Examples 3 and examples 4 want us to plot the point and then find two sets of polar coordinates for each point where the restriction is given that theta must be between 0 and 2 pi. Let's start by plotting the point. So you're given that rectangular coordinate. This here is x and this here is y. We're going to start by plotting the point. Well, the square root of 3 is approximately 1.7, so I know I'm really plotting 3 comma negative 1.7. If I graph that, there would be the point 3 comma negative root 3. Now I need to find two sets of polar coordinates for this point. Let's start with the first one. Well, how do I go from rectangular to polar? I use these formulas. I use the formula that theta is equal to the inverse tangent of y over x, and I use that r is equal to the square root of x squared plus y squared. Let's go for the easy one first. Let's start by finding r. R is going to equal the square root of 3 squared plus negative square root of 3 squared. R is equal to 9 plus 3, or the square root of 12. Well, the square root of 12 is really the square root of 4 times the square root of 3, so r is going to equal 2 square roots of 3. Now I need to find theta. Well, theta is equal to the inverse tangent of y over x. So in this case, theta is equal to the inverse tangent of y, which is negative root 3, over x, which is 3. I encourage you to do this part on the calculator. So I'm going to grab the calculator and show you how to do this on the calculator in degrees. But note, you must convert to radians for your answer. Let's grab the calculator. I need to do the inverse tangent of negative root 3 over 3. Make sure your mode is in degrees because it makes it so much easier to understand if we're in degrees, and then we'll just convert to radians at the end. So I've changed my mode to degree mode. Now I'm using the inverse tangent of negative root 3 over 3. So the inverse tangent of negative square roots of 3 divided by 3 is negative 30 degrees. So I know that theta here is equal to negative 30 degrees. Now, the problem is that theta has to be between 0 and 2 pi. For degrees, that's going to be 0 and 360 degrees. So currently, it's not okay. But before we fix that, we have to ensure that the answer that we just got lies in the correct quadrant. This guy here is supposed to be in quadrant 4, which is perfect because my point lies in quadrant 4. The problem is it's not between 0 and 360 degrees. Why does it have to be between 0 and 360 degrees? Because you are given this as your parameters for finding your points. So how do I get that to be between 0 and 360 degrees? I add 360 degrees to it. So if I add 360, my theta here would equal 330 degrees. So one point, and I'm going to write it first in degrees, and then we're going to convert to radians after we find our second point, because you have to answer in radians, not degrees. But typically it's easier to understand in degrees and then move to radians. But 1 point would be r, which is 2 square roots of 3, and then theta, which is 330 degrees. Again, this is not what you would put into WebAssign or what you would answer on a test because you need to answer in radians, but we're going to do it one at a time. First, both points in degrees, and then finally convert them to radians. So now I need to find a second point. And if you look at the first page, we said that there's a way to get another point. So if we have r comma theta, and I'm going to erase this over here because again, this is on that first page. If you have r comma theta and you want r to then become negative, you have to add to theta 2n plus 1 pi, which was that odd integer multiple of pi. If you have r theta and you want r to stay positive, you have to add to theta 2n pi, or an even integer multiple of pi. Well, in this case, we're not talking about pi, we're talking about 180 degrees. So what we want to do is figure out if I want to try to get r to stay the same, if I want r to stay positive, I need to add an even integer of pi. So that's things like 2 pi or 4 pi or negative 2 pi things like that, which means 360 degrees or 720 degrees or negative 360 degrees. Well, if you have 330 degrees and you add 360, you're outside of your parameters. If you add 720, again, you're outside of your parameters. If you subtract 360, you're outside of your parameters. So you cannot keep R positive. You're going to have to change your R for your second point to be negative. So if R is negative, you have to add an odd integer multiple of pi, which are things like pi or 3 pi or negative pi or negative 3 pi, etc. Well, that would be 180 degrees, 3 pi would be 540 degrees, negative pi would be negative 180 degrees, negative 3 pi would be negative 540 degrees, etc. So if I take this number, if I add 180 to it, again, it's outside of my parameters. I can't do that. Adding 540 would be the same thing, but if I subtract 180 from it, so if I take 330 degrees and I subtract 180, I'm at 150 degrees. That's within the parameters of 0 and 360. That would be my second point. So the 2 points here are 2 root 3, 330 degrees, and negative 2 square root of 3, 150 degrees. But my answer must be in radians, so now I need to convert this to radians. Now remember, to convert your points from degrees to radians, you take your angle and you multiply it by pi over 180 degrees. Now since 330 degrees and 150 degrees are exact values, we're just going to divide them by 180 degrees and keep the pi in the answer. So if you take 330 and you divide that by 180, and then you make that into a fraction, that would be the angle of 11 pi over 6. So 330 degrees equals 11 pi over 6. If we take 150 degrees and we divide it by 180 degrees and then we make that into a fraction, that'll be an angle of 5 pi over 6. So 150 degrees would equal 5 pi over 6. Therefore, the 2 points are going to be the points 2 root 3, comma, 11 pi over 6, and negative 2 root 3, 5 pi over 6. Let's do that again for example 4. The first thing I need to do is plot the point. So this is x and this is y because I'm given rectangular and I need to go to polar. So I'm going to negative 4 on my x and negative 2 on my y. So this is the point negative 4, negative 2. Now I need to figure out what is that in polar. So remember, theta is going to be equal to the inverse tangent of y over x, and r is equal to the square root of x squared plus y squared. Let's find r first because, again, usually that's easier. So this is my x and this is my y. Therefore, r is going to equal negative 4 squared plus negative 2 squared, which is 16 plus 4, or the square root of 20. Well, the square root of 20 cleans up to the square root of 4 times the square root of 5, or 2 square roots of 5. Now I need to find theta. Well, theta is going to equal the inverse tangent of y over x, which is negative 2 over negative 4, which I know is just going to reduce to positive a half. Let's put that in a calculator. The inverse tangent of a half is equal to 26.565 degrees. Theta here is equal to 26.565 degrees. The first thing you need to figure out is what quadrant does that angle lie in. This angle is in quadrant 1, but my point is not in quadrant 1, is it? It's in quadrant 3. To get this angle into the correct quadrant from 1 to 3, I have to add 180 degrees to it. Therefore, if I add 180 to this, I end up with the angle of 206.565 degrees. So 1 point is going to be the point 2 root 5, 206.565 degrees. Now we need to find the second point. Recall, when you're finding the second point, if r remains the same, you're going to have to add some kind of multiple of 360 degrees to this guy here because you're adding an even multiple of pi, so things like 2 pi, 4 pi, 6 pi, etc. But you have the restriction that you have to be between 0 and 360 degrees, so you know that r cannot remain the same. R has to be the opposite. When r is opposite, making it negative in this case, we're going to be adding or subtracting 180 degrees because you have to be an odd integer multiple of pi, so like pi or 3 pi, 5 pi, things like that, which again are odd integer multiples of pi, or things like 180 and then 540, etc. So if I try adding 180 degrees to this, I'm outside of my scope, right? I'm more than 360 degrees. So I know that that can't be what I need to do. But if I take this guy and I subtract 180 degrees from it, I am 26.565 degrees, which is perfect because that meets the restrictions for theta, which are that I need to be between 0 and 360 degrees. So that second point would be at negative 2 square roots of 5, and then 26.565 degrees. But I need to go to radians. I can't answer in degrees. So my two polar points are going to be 2 square roots of 5, comma, I need to figure out what is that in radians. Now, since that wasn't an angle that is known, like 330 degrees, I am going to have to multiply it by pi. Here, if I take 206.565 and I multiply it by pi and divide it by 180 to convert it to radians, I end up with 3.605 radians. So one point is 2 square roots of 5 and 3.065 radians. The second point is that negative 2 square roots of 5. And then I need to get this guy here into radians. Again, since it wasn't an integer, I'm going to have to multiply it by pi to find my answer. If I take this guy here, multiply it by pi, and divide it by 180, I end up with 0.464 radians. So that second point is at negative 2 square roots of 5, 0.464 radians. Again here, because we had 330 degrees, 150 degrees, which are just integers, I left the pi in the answer. But here, since we were decimals, we needed to multiply the pi into our answer.